So we want to prove now, we want to see, we have that the points P, Q, and R are three vectors of a triangle PQR, and it says express each of the vectors PQ, QR, and RP in the form xi plus yj plus zk. All right, so let's do that. So we have vector PQ. First thing we need to know is that vector PQ is going to be equal to OQ minus OP. All right, vector PQ is OQ minus OP. It's always vector of the last minus vector of the first. So it's going to be OQ minus OP. So OQ, remember, let's write out what is OQ. OQ is actually, well, it has in a lambda in it, so let's put it in vector form first, just to be a little bit, safe with lambda. So minus 1 lambda 5, that's OQ, minus OP, and we know that OP is 3 minus 2, and 3 minus 2 and 1. So vector PQ is going to work out to be minus 1 minus 3 is minus 4i, lambda minus minus 2 becomes plus, lambda plus 2 times j, lambda plus 2 times j, and then we have 5 minus 1 is plus 4k. That's vector PQ. Nice and easy, soft. Now let's look at the next part. Now it says find QR. Now vector QR is going to be equal to OR minus OQ. That's vector QR. Vector QR is OR minus OQ. So I need to work out that what is OR minus OQ. OR, as we know it, vector OR is 2i. Again, because it have the lambda, I want to play it safe. Anytime it have lambda, I play it safe. I'm just going to put it in vector form first and then convert it to ijk. So OR is 2, 1 minus 4, 2, 1 minus 4, minus vector OQ, and vector OQ is minus 1 lambda minus, so it's 2, 1 minus 4. This is now minus 1 lambda and 5. So 2 minus minus 1, that works out to be 2 minus minus 1 is 3, so that's 3i, plus 1 minus lambda j, 1 minus lambda j, then you have minus 4 minus 5 is minus 9k. So that's vector QR. Now that we get vector QR, next thing we need is vector RP. Let's work out what's vector RP. Vector RP is equal to OP minus OR. Vector RP is OP minus OR. Alright, since vector RP is OP minus OR, now this one I can just go straight because OP, remember where was OP? This was OP, OP minus OR, this was OR, so OP minus OR, that's going to be 3 minus 2 is 1. That's just I. And you're going to have minus 2 minus minus 1. Minus 2 minus 1 is minus 3j. Let me write this better. minus 3j. Then you're going to have 1 minus minus 4 is plus 5k. Nice and easy, soft. Nice and easy. One minus minus 4, just making sure. Yes, that's 5k. So now we have these, and we're good. Now it says, hence, find the value of lambda given that PQR is a right angled triangle with side PQ as the hypotenuse. So again, guys, I love to see a picture of what's going on. I cannot just do it like that. I have to get a picture. So I'm creating my x and y axis. I know it is x, y, z, but ignore the z coordinates. So OQ is minus 1 lambda. OP is 3 minus 2. So think of it this way. 3 minus 2 is here. So this is OP. Just ignore the z component for now. This will be OP, right? And then you have OR 2, 1, 2, 1, 2, 1, somewhere here. This is R. All right, so remember P is we're only looking at the x and y coordinates. So it's 3 minus 2. R is the point 2, 1. And then we don't know where Q is, but based on what they said that PQ is a hypotenuse. So PQ is the longest side. PQ is the longest side. So where can we put Q? PQ is the hypotenuse. So maybe Q is somewhere here. I'm just putting a point, all right? Just putting a point. Well, actually, Q is minus 1 lambda. Q will be somewhere over here. All right, so let me not draw that yet. Q is somewhere over here. Let's say Q is right here. All right, let's say this is Q. So those are the 3 points, and I'm saying, imagine this now, say have right angle triangle, PQ. PQ is the hypotenuse, and so then that means that the right angle would have to be somewhere at PR. All right, the right angle is somewhere right here. All right, the right angle is somewhere right here. All right, and this is the hypotenuse. And so now we need to determine the value of lambda. To determine the value of lambda, since this is a right angle triangle, then we know that the dot product is 0, or you can know that the angle at R is 0. So generally, what that means is, since we have QR, you know that QR dot PR must be equal to 0, right? So since the angle at R is 90, this is part 2. Looking at the diagram, right, we know that since triangle RPQ is a right angle triangle, since it's a right angle triangle, then what that is telling us then is that QR dot the dot product between QR, so QR dot PR must be equal to 0. So we're going to use that dot product to solve for lambda. So doing that now, QR is 3, 1 minus lambda, minus 9, that's QR, dot RP, dot RP. RP would just be in the opposite direction to this, so this would just be minus 1, positive 3, minus 5, and that's equal to 0. So what does that mean? That implies that 3 times minus 1 is minus 3, plus 3 times 1 minus lambda is 3, minus 3 lambda, and then minus 9 times minus 5, that's plus 45, that's equal to 0. So what does that tell us? That tells us then that 3 lambda minus 3 plus 3 cancel each other, and so 3 lambda is equal to 45. 3 lambda is 45, and so lambda is 15. So lambda equals to 15. That's the answer. Lambda is 15. I don't see why you get 6 marks for this. They were very generous, but that's it. Nice and easy, soft. Lambda is 15. And now we go to module 3. Module 3, we're going to start with question